I'm Eric, and this right here, this guy, this is my silly little friend. This is no chemistry unit 6 topic, so I'll be
Where
teaching.
am I?
First, I'm going to be talking about solutions. Here's the names for all parts of solutions. First we got solute, meaning something you have less of, and solvent, which is something you have more of. Add the two together, you get a solution. There are two other names that you can change your solution with, which is concentrated, which is something that has more solvents and makes the color darker, and dilute, which is something with less solute that changes to a lighter color. Take these two potions for example. This could be a diluted version with less solute, since it's a lighter color. And for another example, we have concentrated, which is more darker and has more solvents. Okay, let's move on. Okay. Here, we got molarity. Okay, it is used when dealing with solutions that involves a chemical reaction. And this is how it's calculated. It can be calculated by dividing the number of moles of solute by volume of the solution in liters. It is used to describe the actual concentration of spices in the solution. So molarity is just basically known as a molar concentration. Okay, let's go over here now.
I don't know where I am.
Okay, my young friend. We're gonna be talking about the pH scale now. Okay, let's start off with the scale from a pH scale, of course. It ranges from 0 to 14. And a pH of 7 is neutral. A pH less than 7 is acidic. And a pH greater than 7 is basic. That's what all these numbers represent. Okay, this is the pH scale's relationship with the acids and bases. Stronger acids have a lower pH value, while stronger bases have higher pH values. And this is how you were to test it. This beacon as water. If you were to have a pH of 0, then the color would be darker, and then it would be acidic. And if the pH is 7, which is the green color right here, oh no, wrong one. Okay, if the pH is 7, then it would be neutral. And the top one, 14, which is the highest, it would be basic.
See, the more concentrated a solution is means that it has more solvent in it, and henceforth it becomes darker over time. And the more diluted it is means that there's less solvent in it, and it becomes a bit brighter.
Yep.
And so the molarity of a solution is the numbers of moles of solute dissolved in 1 liter of a solution.
Got that right.
It is also a common unit when comparing the concentration of different solutions. And last but not least, the number on the pH scale, if it is a number 8 through 14, it is a more basic solution.
Yep.
And if the number is 7, then it is neutral, which is water.
Yep.
And so if the number is below 7, which is 6 to 0, then it is more acidic.
Yep, got that right.
I still have no idea where I am.
Just love
How did we get here? Where are we?
Why the heck is there a factory here? That's bad!
Why is there a factory in the middle of nowhere?
They're burning a lot of fossil fuels in that factory. The CO2 coming from the smoke, which is increasing the atmospheric of CO2. This affects the marine ecosystem by making it harder for organisms like shellfish and corals to build and maintain their calcium carbonate shells and skeletons. They use the bodies of the water, calling it carbon sinks, because they absorb CO2 from the atmosphere. This can affect the corals in the water crucially.
Wait, so you're telling me that because of the factories burning fossil fuels, they're putting out more CO2 than the marine life in the ecosystem can handle, and because the marine life acts as carbon sinks, they're consuming too much CO2, causing it to not get filtered correctly, causing the coral nearby to die?
That's alright. Wait a minute. They're dead! The corals, they're dead! My friend, let this be a valuable lesson to never burn fossil fuels near the water. It can acidify the ocean, and this absorption can lead to a decrease in pH, meaning the ocean becomes more acidic. The specific effect on CO3 can impact the creatures that build their shells or skeletons from the calcium carbonate. This can negatively impact the humans through various pathways, including food security, economic disruption, and potential health effects. This can stop if the people were to implement technologies of carbon captures and storage, enhancing ocean monitoring and research, and supporting the resilience of the marine ecosystems. Well, that's it. I'm done with this dumb factory. I hate it.
Oh my god!
Die, yes! Die!
I have achieved my perfect form, you mortal. Because of the fossil fuels being burned, it impacts the marine life by causing the water to become more toxic, resulting in marine life struggling to live, which interrupts human seafood consumption, which can lead to famine amongst humankind. We can prevent this by reducing our CO2 output and using more alternative ways.